Here the question is a three-hinged arch of span 40 meters and the rise 8 meters carry a concentrated load of 200 kilonewton and 150 kilonewton at a distance of 8 meters and 60 meters from the left, and the UDL of 50 kilonewton on the right half of the span. Find the horizontal thrust. First, we will represent all the things in the diagram form. So here A, B of span 40 meters, and at meter 18 is 200 kilonewton is acting, at 16 is 150 kilonewton is acting. So 16, this is 8. So another half is acting a UDL of 50 kilonewton per meter. So we'll find out the horizontal thrust. Find out the horizontal thrust. So we represent the diagram. The heap is given as 8 meters. 8 meters. Total is of 40 meters. And this is B. The reaction is VB. The reaction at A is VA. Let we take, and the horizontal thrust VH. Here the horizontal thrust is V. We will represent it as vertical reaction VA and VB. Taking moment about A. Moment about A. So we know that 200 into 8 meters, 8 meters, sorry, plus 150 into 16 meters plus 50 into 20, about a 20 meter length, into 20 plus 20 by 2 minus VB into 40 is equal to 0. So VB is 850 kilonewtons. Therefore VA we can get it as 200 plus 150 plus 50 into 20 total load minus 850, that is equal to 500 kilonewtons of VA. Horizontal thrust H, take moments about, we have to calculate the H, moments about C minus H into 8 plus VA into 20 minus 200 into 20 minus 8 minus 150 into 20 minus 16 is equal to 0. So therefore H is equal to 875 kilonewtons. 875, option A is correct. The question is, a cantilever of length 3 meters is carrying a point load of 25 kilonewton at the free end. The moment of inertia is given and the value of modulus of velocity is given. Find the deflection at the free end. We have to calculate the deflection at the free end. We know the relationship delta B at the free end is equal to WLQ by 3EI. By substituting the load, length, and modulus of velocity and moment of inertia, we will get the value of deflection at the free end is 10.71 millimeters. That is option D is correct. According to IS 456 1978, the thickness of the reinforcement concrete footing on piles at its edge is kept at least less than 15 centimeters. This directly we can get it from the code. Question is 2.5 ml of Rasi waste diluted to 250 ml, and DO concentration of the diluted sample at the beginning of BOD test was 8 milligrams meter and 5 milligrams per liter after 5 days of incubation at 20 degrees centigrade. Determine the BOD of Rasi waste. We have to determine the, so dilution factor is equal to 250 by 2.5 ml, that is 150. DO consumed is equal to 8 minus 5, that is 3 milligrams per liter. So BOD of Rasi waste is equal to DO consumed into dilution factor. DO consumed 3 into dilution factor is 100, 300 milligrams per liter, right? The distribution to 300 option C is correct. Is calculate the settling velocity of air particle of smooth spherical solid particle of size d, and the viscosity of air particle is given as mu. So the velocity Vt is density of the particle into d square g by 18 mu. So option A is correct. Question is, Figure shown below shows a simply supported beam that is 75 mm wide and 100 mm deep and 1 meter long. It supports a 2700 kg mass at its midpoint. Neglecting the self weight of the beam, find out the reaction at A. We have to find out the reaction at A. So we know the force is equal to mc. Therefore, 2700 is given into 9.81 as the difference is in terms of 0.5 to 0.2. So we have to take the absolute G value. So 26500 Newton. So RA is equal to RB is equal to force by 2, that is 26.5 by 2, that is 13.2 kilonewton. By this is RA is equal to RB because of the symmetry, it is acting at midpoint. The load is acting at the midpoint. So 13.2 kilonewtons. Option C is correct. It is a direct question. A long plate girder subjected to a maximum bending moment M and which permitted allowable bending stretch is given as FB and the economical depth is given as DE of the plate girder if the thickness of the web is TW is given by. So the economical depth DE is given by 1.21 root of M by FB into TW. So option D is correct. Here the question is, in a falling head permeability test, soil sample of diameter and the length was tested and the commencement of the test. The initial head is given and after 1 hour the head drops to 40 cm. Find out the coefficient of permeability. It is sandpipe diameter is given. So we know that from the falling head permeability test, the permeability is given as 2.303 into A by A into T2 minus T1 time log 10 base 10 given by H1 by H2. So by substituting the values, we know that A is equal to pi by 4 d square is 7.5 centimeters. We are converting into centimeters. It is 44.18 centimeter square. H1 is 80 centimeters to H2 is 40 centimeters. From the data, small a pipe diameter pi by 4 d square is 1 centimeter is 0.785 centimeter square and T2 minus T1 will convert into minutes 1 hour 6 minutes 60 minutes 1 hour, right? That is 3600 seconds, right? By substituting the values in the equation 1, we get K is equal to 1.88 into 10 to the power of minus 5 centimeters per second. So option B is correct. Question is, purely cohesive soil tested by unconfined compressive compression. The mean unconfined compressive strength obtained as QU is given as 50 kilonewton per square meter. That is, we can say it as 50,000 Newton per square meter. So that we can find out the cohesion is of QU, that is 25,000 Newton per square meter, that is 2500 kg per square meter approximately. So estimate the ultimate bearing capacity using Terzaghi concept. So the Terzaghi bearing capacity factor NC is given as 5.7 from the question. So the ultimate bearing capacity QF is 2500 QU, we can say 2500 into 5.7, that is 14,250 kg per square meter. 14,250, option A is correct.